In the first part of 7.5, we learned how to find the greatest common factor. Again, what does greatest common factor mean? What does it mean when it tells us to find the greatest common factor?
Biggest number.
Biggest number that goes into both, right? So, any guesses on 24 and 40?
8.
I heard 8. I also heard 4 earlier.
2.
I heard 2. Okay. What do we do if we're guessing and we're not sure? Factor trees. Yep. 24. What are two numbers that multiply to give you 24? 8 and 3. You could have also used other pairs, okay? Right? Break apart 8 with 4 and 2. What about 4? 2 and 2. Can we break apart any more of them? No. Move on to 40. What are two numbers that multiply to 40? 8 and 5. What can I break apart? 8, 2, 4 and 2. And then same thing with 4 is 2 and 2. After we're done with the factor tree, what do we do from here? Line them up, right? Make your list. 24 has what in its list?
2, 2, 2, 2, 4,
3 2s and a 3. What about 40?
It has 5, 2, 2, 2.
3 2s and a 5. Once we have our list, what do we do? Find what they have in common, right? What do they have in common? They have a 2, so I'm going to take a 2 to represent that pair. Okay? Then they have another 2, take a 2 to represent that pair. And then they have another one, right? Times 2. Okay, what do we do with those three terms? Multiply. What do we get when we multiply? 8. Okay? So if you guessed 8 at the beginning, nice job. Okay? Any questions on that example with greatest common factor? Okay. And try this one. Try this one. Practice. So, 9, I heard. Was there any other ones?
Nope.
Okay. Let's check. If I start with 27, what are two numbers that multiply to give you 27? 9 and 3. Break apart 9 to 3 and 3. Now go on to 36. 9 and 4. 9 again goes to 3 and 3. 4 goes to 2 and 2. Awesome. Okay. Now we make our list. We have 27. What's left with 27? 3 3s, right? What about 36? 2 2s and 2 3s. What do I have to remember before we start doing pairs? What did we have at the beginning? Letters, right? What did we have with 27? X and Y. 36 had X, Y. Now we can look for what? Pairs. What they have in common. 3. Write a 3 to represent that pair. Another 3. What else do they have? They have an X. And they also have a Y. What do we do with those four terms? Multiply 9, and then what happens to X, Y? It's just written right next to it, right? X and Y. So, was our beginning prediction correct? Yes. Okay, awesome. Sooner or later, you won't have to do the factor trees anymore. You'll get used to it. Okay? All right. What about this one? What's different about this one? It has exponents. Okay? Let's do the same thing we normally do with the numbers. Focus on the numbers first. What's a greatest common factor of 12 and 18? 6. Does everyone agree? Can we go higher? No. Okay. 6 is the greatest common factor. Now, what do we do about the exponents? What does x squared mean? X times x. So I'm going to start with 12. How many x's does 12 have? Has 2 x's, right? Exponent tells you how many it has. How many y's does it have? How many y's does 12 have? It has 1. Okay, moving on to 18. How many x's does 18 have? 1. How many y's does 18 have? 2. Okay, we already said that 6 was our number. That's great. Okay, but we can still make our list with our variables to help us out until we get more comfortable. Okay, what do they have in common in their list? They have an x and they have a y. Multiply those together. 6 x, y. Yep. Good. Another way you could do it is you could look at your exponents. So x squared, and what exponent's technically here? Not 0. 1. Yep, I meant to make it a circle, not a 0. So we have x squared and x to the first. 12 has 2 x's. 18 has 1. So how many do they have in common?
1.
They only have 1, right? One of them has 2. The other one only has 1. So they only have 1 in common. So the exponent that is the smallest, that's how many you need. Okay, and see in our final answer we had 1x. And then with the y, we have y to the first and y to the second. So how many y's do we have in common? 1, right? The smallest one. Okay. Any questions on those? Okay. Are we comfortable with greatest common factor? Yeah? Okay. Moving on to today's, if you don't have your notes from yesterday, just rewrite these on the piece of paper that you have. Okay? We're going to get into factoring today. Okay? Raise your hand if you know what I mean by factor. Raise your hand if you have no idea what I mean by factor. It's okay. Okay? We are going to deal with greatest common factor still. Okay? So looking at 12x and 48, what's a greatest common factor? Does everyone agree? If you didn't know, what could you do? Factor trees. Yep. But to save time for practice later, it is 12. Do they have a variable in common? No, right? So we are going to take 12. 12 is our greatest common factor. So what factor means is we're going to take that out of every term. Okay? So 12 is what I'm taking out. With the 12, I'm going to start a set of parentheses. Okay? We're going to divide every term by 12. So if I take 12x divided by 12, what am I going to have left? X, right? 12s cancel out, so we're going to be left with just x. That's what's left in the inside. Okay? Same thing with 48. We're going to take 48 divided by 12. What does that give us? 4. So we're going to have x plus 4 on the inside. Okay? Now, how can we check if we did it right? We could distribute it back, right? 12 times x gives us 12x. 12 times 4 gives us 48. Did we do it right? Yes. Okay? And the inside is in simplest form. Okay? What do you notice on B?
It's not, they can't be multiplied.
There's no factor, right? We don't have a greatest common factor that goes into 3 and 11. So what do we do?
You have to multiply until they both get the same number.
Can we do anything? No. So your final answer is just 3x plus 11. That's already in its simplest form. So you don't have to do anything with that one.
What would you do? What one is it where you do that?
You're thinking of elimination. Okay? Any questions so far? We're going to do a couple examples together. Okay? Let's look at this one. 15x squared plus 18x. In order to factor, what do we need to find?
The
Greatest common factor. Okay? Look, numbers first. What's the greatest common factor of 15 and 18?
3.
3. Is there anyone higher?
Nope.
We agree with 3?
Yep.
All right. 3. What else do they have in common?
X.
How many x's?
2. 1.
What's the trick with the exponents?
You do how many 1?
We have 2 here,
And then
1 here. Take the one that's the smallest.
So just 1.
So they only have 1x that's in common. Okay? So x is also a part of our greatest common factor. Is everyone okay so far? Okay. What do we do with the greatest common factor now? Divide it, right? So we have, I'm going to write up here, 15x squared divided by 3x. Do the numbers first. What's 15 divided by 3?
5.
5. Way back when. Remember this?
Nope.
X squared divided by x. What do we do with the exponents when they have the same base when we're dividing? Yeah, subtract. We're going to subtract our exponents. 2 minus 1, 1. So we're left with x to the first, right? Remember? We took our exponents 2 minus 1, so we get x to the first power. That is what goes in for 15x squared. Now we got to do the same thing for 18x. 18x divided by 3x. Numbers first. 18 divided by 3? 6. What number is on our exponents right now? 1. What do we do with the exponents? Subtract 1 minus 1? 0. So we're not left with any x. Okay. Let me explain another way to think about the x's that might help. Okay. Here, focus on the 15x squared first. We have how many x's to start? We have 2 x's to start. We're taking 1 away. So how many should we have left? 1. 18 had 1 x to start. I'm taking 1 away. How many does it have left? 0. So you can think about it that way also. Okay? So what our greatest common factor is doing is we're taking it out. We're dividing it out of every term in the expression. Does that make sense? Yep. Okay, don't worry. We're going to get a lot more practice at this stuff, okay?